Here we go.
Here we go.
Lesson 2.6, graphs of rational functions. So first of all, rational function. Rational function is written in the form f of x over g of x, where f of x and g of x are both polynomial functions. So notice when we talk rational, you guys remember what rational means? Anything that can be expressed as a fraction. Okay, so, or a terminating decimal. Okay, but anything can be expressed as a fraction. So that's the type of stuff we're graphing and looking at today, is these rational functions. Now, as we look at this, we are dealing a lot with limits today. I know this part 1 says find the domain, and that's all it really says. But we're going to do a little bit more than just that. But when we find the domain, we're going to find the domain using limit notation. And so as you go through your homework tonight, you're going to be using lots of limit notation.
Is that not the same as the limit x arrow infinity?
Yeah, it's similar to the limit notation we used previously back in, it was 2.3 or 2.4, I think 2.4. No, 2.3, I don't know.
On the test.
We had it on the quiz, okay? We're going to go a little bit more into that. We're going to have a little bit, more variation stuff. Now, when we talk about this, it talks about domain. So, first of all, what do you know about denominator? Denominator cannot equal 0, yes? So if we set our denominator equal to 0, what does that mean is true in this problem? X equals 2, right? So if we set x minus 2 equal to 0, you're going to solve and get x equals 2. And so that means x cannot equal 2 in this problem. Do you remember what occurs at that point? Vertical asymptote? Remember? Okay. If you set your denominator equal to 0, in this case we got x equals 2, that is a vertical asymptote because x will never be able to be 2. And so, right there, vertical asymptote at x equals 2. So that's one thing we know about this graph, is that whatever this graph is doing, there's going to be a vertical asymptote at x equals 2. We will not have any x equals 2 values. Now, do you guys know anything about what this graph looks like? Okay. You guys remember what the graph 1 over x looks like? No? It's 1 over 12. Remember, it's the reciprocal function. 1 over x are those, it's our hyperbola, well, I guess it'd be this way most of the time. So 1 over x is this, the two pieces that go out. If there's a minus 2 in the denominator, that just means that the graph is going to move 2 to the right. And so, here's the calculated version of it. Do you see that reciprocal function there? It's normally in first and third quadrants. Take it, move it to right, and what's happening? Can you see the asymptote at 2? Or let me rephrase that. Can you see where the asymptote would be?
Yeah.
Okay, the asymptote's not actually there, but we can see where it would be. So I'm going to sketch this graph in my notes. And then we're going to talk about some various limit notation. So there's a vertical asymptote at 2. And then my graphs are in the equivalence of first quadrant and third quadrant. When we talk about using limit notation for the domain, we are talking about using limit notation in relationship to our vertical asymptote. Our vertical asymptote is 2, right? So our limits that we're going to be looking at is what happens on either side of 2. What happens as x approaches 2 from the left side, and what happens as x approaches 2 from the right side. And those are the two limits we're going to write. So let me write these out so you can see the notation. Overall on the quiz, you guys did a fairly decent job of copying down the limit notation and writing it as I wrote it. Keep at that though. There are a few stragglers that weren't quite there with it. The notation is important that you use proper notation here, not just whatever makes you happy. So the limit, as x approaches 2 from the left, how we put that is we put a negative sign after the 2. And what that's saying is the limit as x approaches 2 from the negative side, which the negative side is the left side of f of x equals. That's one of the limits we're going to be finding. The other limit we're going to be finding is the limit as x approaches 2 from the positive side, which means from the right side. So because my vertical asymptote is 2, we're looking at the limit from the left, the limit from the right. Okay, ready to talk about what these equal? As x approaches 2 from the negative. So as I come from the negative, as I come from the left, and as I get closer to 2, where is my graph going? Down. How do we say down? Negative infinity, yes. Because we're going to go down here on this graph to negative infinity. So this first limit equals negative infinity. And again, that negative infinity represents the fact that my graph is going down. I try and keep throwing those ups and downs, lefts and rights in there so you can understand how this notation works. I'm going to put on the bottom that this one is as x approaches 2 from the left. As x approaches 2 from the left. That's what that first limit is asking. Or from the negative side. Now look at the second graph. This one is the limit as x approaches 2 from the positive side. So, from the positive side means from the right. What's my graph doing as we get closer to 2 from the right? It's going to go where? It's going to go up, which is going towards positive infinity. So this limit is equal to positive infinity. Again, what does that positive infinity represent? That represents up. And this notation here was as x approaches 2 from the positive side, or I tend to just say the right side. So that's one set of limits you need to be able to write. And you write those limits every time we have a vertical asymptote. Whatever that vertical asymptote was, in this case it was 2. So what's my graph doing as we approach that 2 from the left and from the right? Now, it only talked about domain here, but I want to use this opportunity to also, that was vertical asymptotes, I also want to talk about horizontal asymptotes. And I'm going to use this little section here. When we talk about horizontal asymptotes, first of all, by looking at that graph, can you guess where there's a horizontal asymptote? Where do you see a horizontal asymptote happening there? Okay. Technically, it'd be y equals 0. It's the x-axis, yes? Because we can see on the right, it's running on top of the x-axis. On the left, it's running underneath the x-axis, right? So that, in that equation, is y equals 0. So there's a horizontal asymptote at y equals 0. Do you remember how my horizontal asymptote rules work when we look at the equation? When the bigger power is in the denominator, my horizontal asymptote is y equals 0. Okay? Now, how do we write the limits for this? Horizontal asymptotes run this way, yes? Horizontal asymptotes also refer to end behavior. So this is what is my graph doing on the ends as we go all the way left and all the way right. And so when we write these limits, it's as x approaches negative infinity and positive infinity. What is my graph doing? So I'm going to write those limits. The limit as x approaches negative infinity of f of x, and the limit as x approaches positive infinity of f of x. I'll write that down. We'll zoom into this part, and then we'll talk about it. Okay, you ready? As x approaches negative infinity. So as x approaches negative infinity, says as my x values go off to the left. What y value is my graph approaching? What's it getting closer to? Well, no, as my x values go to negative infinity, what y value is this getting closer to? It's getting closer to that y-axis or x-axis, which is 0. Yes? Okay, what about on the right side? As we go, as x approaches positive infinity, where does my graph getting closer to in terms of y values? 0. Both of these limits equal 0. They equal each other. They equal 0. And your horizontal limits will always equal each other. Okay? Because it's that horizontal asymptote. At the left it's 0, at the right it's 0. That's the other set of types of limits. So we'll write limits for horizontal asymptotes, limits for vertical asymptotes. Got the gist of it? Now, we're going to do 2 examples like that. I've kind of already shared, I think, most of this. In behavior asymptotes, basically horizontal asymptotes. Vertical asymptotes, when do they happen? Where the denominator equals 0? Okay, in part 2, my plan is to do A and B. And I'm pretty much going to take up all that space. So you can kind of allot half and half if you want. Part 2, it says find the asymptotes. We're going to write limits again. So we're going to write a set of limits for the vertical asymptote, a set of limits for the horizontal asymptote. Before I graph this, can you tell me what the asymptotes are going to be? Well, you have to have a number in there. 0. Why? Okay, so vertical asymptote. Set the denominator equal to 0. What's my denominator equal to 0? Negative 3. So that means, I'll write it out here in a moment, there's going to be a vertical asymptote at negative 3. Bigger power is on the bottom. That means my horizontal asymptote is y equals 0. So as I think about this graph, I'm going to sketch my graph over here. We just said there's a vertical asymptote at negative 3, yes? We also said there's a horizontal asymptote at y equals 0. And again, notice this is an x in the denominator. So can you visualize what this graph is going to look like? It's similar to what we had last time, where it's that reciprocal function. So it's 2 over x plus 3. Basically, it's taking my reciprocal function and scooting it left 3 to that vertical asymptote. So we've got a graph here and a graph here. Can you guys tell by looking at the graph that there's a vertical asymptote at negative 3? Okay, and that's something good to be able to tell. However, can you also tell by looking at the equation there's a vertical asymptote at -3? And that's yes, because the denominator is equal to 0. Okay, so the limits. First of all, let's focus on the fact there's a vertical asymptote at x equals -3, yes? So what are the two limits I'm going to write based on that one? The limit as x approaches 3 from the left, and as x approaches 3 from the right. Those are the two limits you're going to write. So the limit as x approaches -3 from the left means I put a negative sign after it. F of x equals. And then the limit as x approaches -3 from the right means I put a positive sign after it.
We're doing A, B, and C.
We're doing A and B. Yeah. I'm already try not to go into B because you're going to use the area under B and C for B. Okay, so first one, the limit as x approaches -3 from the left. As we approach -3 from the left, where is my graph going? Down, which is -infinity. Because as I get closer to that asymptote on the left, my graph starts going down, and that is -infinity. What about on the other side? As x approaches -3 from the right, where's my graph going? Up, which is +infinity. Those are the two limits we write for vertical asymptotes. Anytime you have a vertical asymptote, you write two limits. So if you have two vertical asymptotes, then you're writing two sets of limits. Okay, horizontal asymptote. What did we say the horizontal asymptote was? Y equals 0. Now your horizontal limits are always the same because horizontally I want to know what my graph's doing as I go -infinity and as I go +infinity. So my horizontal limits are always going to be the limit as x approaches -infinity of f of x and the limit as x approaches +infinity of f of x. Can you guys see that? I kind of goofed my negative. Let me try that again. Good enough. I'm afraid if I mess with it too much, I'm going to make it worse. Okay. Horizontal asymptote is y equals 0, right? As I approach -infinity. So that means as my x values get smaller and smaller and smaller and go farther left, 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 where's my graph going?
0.
It's going to 0 because it's going to run alongside that y equals 0. As my x values get bigger, so as I go farther to the right, what y value is my graph approaching? 0. So what do both of these limits equal? 0. And again, did you guys remember me saying your horizontal limits will always equal the same thing? And they equal whatever that horizontal asymptote is. Got it? Okay. When you're ready, I want to try B. As I said, we're not going to do C. I'm going to sketch a small graph up top. I know there's not a lot of room, but again, something to visual. What kind of vertical asymptote am I going to have? X equals 2? Are you guys okay with that? So if I'm going to have, and I'm just going to go ahead and write it here. It's a vertical asymptote of x equal 2, because that's setting your denominator equal to 0. Okay. Review of rules. What kind of horizontal asymptote am I going to have? I disagree on both counts. Okay. What do you notice about the powers, guys? Greatest power on top and greatest power on the bottom are the same. When the greatest powers are the same, we look at the leading coefficients. My leading coefficients are 3 and 1. And 3 over 1 is 3. So that means my horizontal asymptote is going to be y equals 3. And so that means in my graph, 1, 2, 3 up, I have a horizontal asymptote there. Now, do you see how those asymptotes shifted? What's that means going to happen with my graph? My hyperbolas, that reciprocal function, are going to shift where? 2 right, 3 up. Now, however, they do switch quadrants on this one too, I believe. Let's look at it on the calculator. 3x minus 7 over x minus 2. You should feel confident about your asymptotes anyways, but does this make sense? Does it make sense that we said there's an asymptote at 2? A vertical asymptote at 2? Does it make sense that we said there's a horizontal asymptote at 3? It does. And it should with your graph. So you can draw these graphs in. Now notice, instead of being the equivalence of quadrants 1 and 3, this is the equivalence of quadrants 2 and 4. Okay. What are the limits I write for the vertical asymptote? The limit as x approaches 2 from the left and 2 from the right. Practice writing that notation. The limit as x approaches 2 from the negative of f of x equals, and the limit as x approaches 2 from the positive of f of x equals. Okay. Look at this, guys. The limit as x approaches 2 from the left. What's my graph doing as I approach this x value of 2? So as I approach this vertical asymptote, it's going up, which is positive infinity. Okay. As we approach x from the right, so as I come from the right and approach that vertical asymptote, where's my graph going? Down, which is negative infinity. What are the limits I need to write for horizontal asymptotes? It's always what?
The same.
And what are those limits? As x approaches... Okay, the limits are as x approaches negative infinity and positive infinity. Without even looking at the graph, Aiden's telling me that they're going to equal 3. I was looking for that first. Okay, I was looking for that. And that. So you're always writing the limits for horizontal asymptotes. As x approaches negative infinity, what's happening? And as x is approaching positive infinity, what's happening? So as x is going off to the left forever, and as x is going off to the right forever. Well, on the left, it's running on top of what number? 3. On the right, it's running on bottom of what number? 3. So these both equal 3. And you could write that they equal 3 individually, but I'm trying to make the point that they're the same. Yes?
So, because when we find the horizontal asymptote, like at the beginning, both times it's equal to the horizontal asymptote, so would it just...
It always will.
Okay.
You're talking about these limits right here?
Yeah, and then
Yeah.
Okay.
Yeah. Our horizontal will always write as x approaches negative and positive infinity, and it'll always equal whatever that horizontal asymptote is. Okay? It's not a coincidence. It will always happen. Okay, I want to look at one of these graphs down below. That's all we'll have time for, honestly. So, now, there it gives us 4 points, and it says what we need to know to graph rational functions. I'll be honest, at pre-cal level, you guys aren't going to quite know everything you need to graph rational functions. Okay, that's something more we do at the calculus level. However, there are pieces that I want you guys to know, pieces that you should know, that we can use to put together a graph. I'm just not 100% holding you responsible for the whole thing. So the 4 things that we're going to look at in behavior asymptotes. What have I said about in behavior asymptotes? Those are essentially looking at our horizontal asymptotes. I mean, you want to get technical. In behavior asymptotes also include the slant asymptotes. But more often than not, we're just talking horizontal asymptotes. Vertical asymptotes. We'll look at vertical asymptotes. How do we find vertical asymptotes? That's when we set the denominator equal to 0. We're going to look at x-intercepts. We know x-intercepts are where the graph crosses the x-axis up there. So it's when you cross the x-axis. Officially, it's when y equals 0. Well, these are functions, or these are fractions is the word I want. When do fractions equal 0? When their numerator equals 0. So since these are fractions, we'll set the numerator equal to 0 to find the x-intercept. And y-intercepts, where we cross the y-axis, well, where we cross the y-axis is when x equals 0. And so that's when they talk about f of 0, is because you're putting in 0 for x. So those are the 4 pieces we're going to look at. We're going to do graph number 2. And then we'll do what we can, and I can show it to you on the graphing calculator as well.
So on the homework, is it going to be more like finding limits and then doing graphs?
It is. There's a lot of limits to write out in homework. There's a few where they give you the limits. You just have to stay with the equal. And then there's a couple, and I don't remember if you actually have to graph them or if it's more about finding these 4 sets of information. Okay, so the first thing up above was in behavior, or in other words, horizontal asymptotes. Any thoughts as we look at graph 2 about horizontal asymptotes here? Okay. Larger power on the bottom. So that is y equals 0. And I will even put it in words here. Bigger power on bottom. I've tried to review those horizontal asymptote rules as we've gone today, but you've got to know them. Vertical asymptotes. How do we find vertical asymptotes? Set the denominator equal to 0. Now, technically, we probably should have done this to begin with. What should I back up and do with that denominator first? Factor it. So I probably should have done that to begin with. We already know our numerator is x minus 1. X squared minus x minus 6. Does it factor? I hope so. Otherwise, this problem is not so nice. X squared is x times x. Okay. X plus 2, x minus 3. Because it multiplies to be negative 6 and adds to be negative 1. So if my denominator factors into x plus 2 and x minus 3, what are my vertical asymptotes? X equals negative 2. And x equals 3. You know what? I meant to do this as I went along. I'm going to go ahead. Can we draw that horizontal asymptote on the graph down below? Yeah, it's just doing a dotted line along the x-axis, right? Can I go ahead and do vertical asymptotes? At negative 2, which means I go 2 left. And at positive 3, which means I go 3 right, okay. Point 3, x-intercepts. It's where y equals 0, or when it's a fraction, the shortcut is to set the numerator equal to 0. What kind of x-intercepts am I going to have here? So the numerator equals 0, x equals 1. Or in other words, the ordered pair 1, 0 if you prefer. So that means my graph is going to have to cross through at 1. I'm putting a dot there because that indicates I'm going to cross through that point. Item 4 is, if you look up above, y-intercepts. How did it say we find y-intercept? 0 for x. Up above I put x equals 0. So if we put in 0 for x, 0, 0, 0. What do I have? Negative 1 over negative 6. What's a negative divided by a negative? Positive. So what's my y-intercept? Y-intercept? Can't say that right. Positive 1/6. Or in other words, the ordered pair 0, 1/6 if you want ordered pair. Now that's a y-intercept, right? So y-intercept is on the y-axis. If here's 1, then my 1/6 is going to be just up from the origin. Okay, we got all of that information. Officially, we're ready to graph this. Now this is where I'll go with, you guys don't quite know everything you need to know to graph this, but look at this. Okay, before we show it on the graphing cat there, well, first of all, the idea of vertical asymptotes is that my graph is not going to cross them, right? It's going to run alongside them, but cross them. And so we know we're not crossing -2, we're not crossing 3. The graph will jump over them, but it won't actually cross through it. So it'll be a disconnected graph. Now, horizontal asymptotes. Let me state, horizontal asymptotes follow a little bit different rules. As you go off left and right, we will not cross the asymptote, the horizontal asymptote. However, notice what we're set up to do here. In the middle, we are set up to cross the horizontal asymptote, and that is true. Horizontal asymptotes you can cross in the middle, just now as they go off to the positive and negative infinity. Different set of rules, just how it works. Now think about this. If we're not going to cross -2, we're not going to cross 3, how's my graph going to go through both of these points? Not a parabola, more like a reverse cubic. Because what's going to have to happen is we're going to have to come from below, cross through 1, 0, go over and cross through 0, 1, 6, and then we can't go back down. Because do I have a way to cross through the x-axis again? No, we're going to go like this. And I guess it could be a parabola if it just touched at 1. But I only have a multiplicity of 1 here, so it crosses through at 1. See how I'm putting all those, I randomly threw the word multiplicity in there. There's a reason we're learning all this stuff. Now, this is not the only part of the graph. The other thing, and this is again where I teach this more in calculus than pre-cal, at asymptotes, the general rule of thumb with asymptotes, unless there's even multiplicities, but nothing here has a bigger multiplicity than 1, your signs will always change at vertical asymptotes. Like right here, since my graph is negative, on the other side of this graph, or on this other side of this asymptote, my graph would have been positive. So I would have this little piece right here. As it's going out to infinity, it can't cross, so it's going to run along the x-axis. Over here at -2, my graph is positive here, which means and when I jump to the other side of the -2 asymptote, my graph is negative. Again, we can't cross that horizontal asymptote as we go out to the left, so it's going to run alongside underneath it. And your graph looks something like that. Okay. Let me pull it up here so I can kind of show you in case you're curious. Now, do I fully expect you guys to know all that exactly? No, I mean, that's, it's weird because they tell us to graph these, but nowhere in this book do they really talk about at asymptotes how you switch signs. But does that look similar to what we graphed? It does. Okay. So I'm more going to focus on, okay, can you find those pieces? The horizontal, the vertical, the x-intercepts, the y-intercepts. Can you use that to get your basic graph? Honestly, once you get that stuff and you learn these rules, you pretty much know what it's going to look like. Okay. Questions there? There's my homework line down there, guys. There's a line underneath the word homework, underneath the abbreviation homework. Well, I didn't want to draw a big long line, so use the bottom of the page as your line. Page 225, 2 through 10 evens. You're writing a bunch of limits there. Limits for your horizontals, limits for your verticals. 11 through 18 all. I think that one's where you're answering what the limit equals. And then 20 through 30 evens, some of that is limits, and then some of it is what we were doing here, like horizontal, vertical, asymptotes, and your intercepts. Okay? Have that ready to go for tomorrow, please.